All right. So inflation 13, the homework assignment, I've got that here. Looking into the future, quiz 6 we're going to have next time. Good news is that's the last quiz. We won't have any more quizzes for the whole semester after this one on Thursday. And we're going to be meeting here in this normal classroom again on Thursday. Also on Thursday the 17th of December, you'll have homework 14 due. And so that's a little bit more time than we've usually had between assignments. So, you know, you've got an extra long time for the cost estimation assignment. I haven't handed that out to you yet, but I'll give that to you when we meet on Thursday. Today we're going to begin on Chapter 15, and we're going to spend several lectures on that. If you're following along in the book, the content we're covering today is Section 1 and 2 of Chapter 15. And what we're going to be learning about today is called the unit method. So let's get into that unless there's any questions on the announcements. Yeah. No. All right. We've already talked about fixed cost and variable costs in the past. And so we've thought about costs being in different types of categories. There's a new kind of category of costs that we're going to start talking about in Chapter 15 when we're doing cost estimation. And the two different categories we're going to be thinking about are direct costs versus indirect costs. And this is kind of a little bit abstract. It's hard to understand at first, but we'll try and identify a few examples to make it a little bit more clear. Direct costs are the things that you can tie directly to your activity or to the production of some good. So it's allocated in italics there. It says to a specific output or work activity. And it's easy to know exactly what your direct costs are because what you're making or what you're doing has a specific requirement for whatever these direct costs are. So let's think of an example. Materials, laborer salaries, production expenses. Let's say that you're making a bridge for a highway. The direct cost for a highway bridge would be the volume of concrete that goes into that highway bridge, the amount of reinforcing steel, and you know those things because it's specified by the engineer that designed it. There won't be any ambiguity on what those costs are. You can call your supplier, ask them what's the volume, what's the price per volume of concrete, what's the price per pound of steel, and so on. With the laborer expenses, what you can find out from your accounting department is per hour, what does it cost us to have the laborers on the site? And so those are directly attributable to whatever it is that you're making. But some things are a little bit more vague, and those are what we call the indirect costs. They're not easily allocated to a task. So for example, when you think about the supervisors that may be on site during the construction of that highway bridge, how many supervisors does it take to make a bridge? It's not on the plans, right? The plans that the structural engineer produces, it may say the volume of concrete, it may say the amount of reinforcing steel, but it doesn't say, and we need 3 supervisors on site for a total of 87 hours. And it definitely doesn't say what the supervisors should be paid. You know, that's something that's a lot more difficult to find out. And so it's not easily allocated to a specific task. If you're manufacturing phones, for example, you don't know how many advertising dollars is required to go into selling a phone. Because some companies advertise a lot, and some phone companies, you've never heard of them before you went to Dragon Mart, right? When you go to Dragon Mart, you'll be walking through there, and there's all sorts of brands you never heard of before. Weird names of things. And so some other examples of indirect costs are computer systems, accounting services, the rent of a building. And the reason why building rent would be considered an indirect cost is because you never really know exactly how many phones you can make in a certain square footage of factory space. And so it's not directly attributable to the output of whatever's being made. So direct costs and indirect costs. Any questions so far about that? There was an article in the paper yesterday about AUS. I just noticed it as I was looking through the headlines, and it was talking about the board meeting that was held recently. And one of the things in this article it was summarizing was that the university has increased. You don't want to put it in that pile. That's the returned assignments. It'll never get graded if you put it there. Getting warmer. Keep looking. Look for the cover sheets that look exactly. There you go. Found it. All right. So the university previously has been using a recovery rate of 27%. And so what that means is if a professor is having a research project, let's say that a professor gets 1 million dirhams from a funding agency to do research. For every dirham that professor spends, the university would take 27% of it, just to cover things like the building expenses, electricity. It would cover things like, when the university is sponsoring visa fees and so on, just the cost of operating the university. What's that? Yeah, machinery in the labs, lab equipment, definitely. So in the past, the recovery rate was 27% previously, which was actually on the low end, because most universities are charging somewhere in the 40s. This 42% that they went to now, that's more typical of what universities across the world are charging for their indirect cost recovery. And in fact, there are some universities that charge even 50% or more. So you can think of it, it's like a tax that the university is taking for the privilege of hosting research on its premises. So it was, I thought, ironic that on the same day that I'm preparing a lecture about indirect costs, I noticed a headline where it said that the university is changing their indirect cost recovery rate. This is a change that actually most of the professors will be really sad about, because it means that the university is taking more of the money that they're bringing in for research. So it means less money that the professor can spend on the equipment that they need and hiring graduate students, and more that the university is going to keep to cover the costs that it has. Any questions about indirect costs? All right. I made it through several more of the student submissions for the project. I still have maybe 10 more to go. I'm working through those. And one of the things that I'm noticing is that sometimes students are just saying, I will spend 10,000 dirhams on food. And so I'm thinking, really? Exactly 10,000 dirhams? What a coincidence that the amount of food you need to eat is a nice round number like that, 10,000 dirhams in a year. That's like a perfect coincidence. It doesn't seem like some of the estimates are based on any kind of reality or any kind of analysis of, I'll eat 20 kilograms of mutton, I'll eat 15 kilograms of fish, like no individual subcategory budget. And so that's some of the advice I'm giving to students is think in more detail about what your estimates are supposed to represent. You have a question? Yeah. The concern I have about that is think about the range of people that live in Dubai. You have laborers who are watering grass, and you have billionaires who are living at the top of the Burj Khalifa. And so like this website, is that an average, meaning it took the entire population and how much they spend and divide it by the number of people? It's difficult to say whether it would accurately represent your behavior and your habits. And so I think it's better if you do what's called a bottom-up approach. In a bottom-up approach, you look at, rather than setting a budget for how much you're going to spend, you'll look at the actual expenses that you anticipate incurring. And so here is an illustration of if you're going to be making something, how do you know what price to charge for it? The bottom-up approach is what you would use if there's not really a lot of competition in the market and you just need to charge enough to pay for the cost of making an item plus some profit. Apple is able to do the bottom-up approach, because when they make a new product, no one else is making it, or no one else is making it as well as they are going to introduce a new product. For example, when they came out with the iPhone, there were other people who were making phones that could connect to the internet, but it wasn't exactly the same. And so what the bottom-up approach does is it looks at individual subcategories. For example, how much do we need to recover in order to pay for the capital recovery, the paying off the equipment that was used for manufacturing? What is the direct cost of the materials that goes into the item? And have any of you ever heard of the websites where when there's a new product release, they'll open it up, tear it down, and then they'll say, all right, in this new smartphone, we see it has this RAM modules, it has a certain screen, it's got a certain processor. They literally break apart a brand new phone and then they list all of the components in it, and they actually know what those components cost, and so they compare the price of what's being charged for an item to the cost of the components that are in it. So here in this bottom-up approach, it's saying that you can know the expense of the materials that are used for production. You can factor in a cost of the labor, which is, the assembly, the labor required for packaging it, the labor required for shipping and marketing and so on. Expenses for maintaining equipment and operational expenses like the supervisory salaries. And then the indirect costs. What are indirect costs? Just to go back to where we were previously. When it's talking about the indirect costs here, what sort of expenses that aren't listed in the things below it would go towards the indirect costs? Yeah?
Maybe adding some water because of increasing temperature or sudden problem with water.
So you're saying like a safety factor? That could be part of it. The indirect costs really are just the things that you can't exactly know how much of it is required to make the item or to do the activity. So it could be marketing costs. Sometimes the indirect costs may be the electricity that's used, or it could be the insurance on the operation. So you add up both the direct costs and the indirect costs, and then you add the profit that you'd want to make, and then that gives you the price that you should charge. So that's the idea of the bottom-up approach. It's where you're starting from the bottom, and you're looking at how much it actually costs to make something, or how much it costs to do something. When you are calculating your expenses, you should use the bottom-up approach for the project. All right. The other kind of cost estimation technique is called the top-down approach. And you would use the top-down approach when you're trying to manufacture something in a very competitive environment. Let's say that you're not making a cutting-edge smartphone that's going to do something that no one has ever done before, but let's say you're copying everyone else. You're making a commodity. You're making a phone with sort of just middle-range specifications, and it really doesn't have any distinguishing factors between anyone else. And so no one is going to choose your phone because it has amazing features. They're just going to choose it because it has a competitive price. So in the top-down approach, it's sometimes called the competitive price. The price is the starting point rather than the ending point. Remember, in the bottom-up, the last thing we figured out was how much we're going to charge. And we knew that based on all of the factors that build into the price. Here, with the top-down approach, it's sort of like you're setting a budget. You're saying, for this phone we're going to make, we can only charge 800 dirhams. So that's the most we're going to get. All of these amounts have to be covered by that 800 dirhams that we can get from the customer. And so you're starting at the top, which is the sales price, and you're figuring out, based on that sales price, how much profit can you keep, how much can you cover your indirect costs, and how much can be allocated to each of these other categories. And it's a very useful technique to use when you tell your engineers, we have to meet a goal, so figure out some new ideas. Figure out a way to make the assembly line more efficient. Figure out a way to make the RAM modules cheaper, and so on. When you have a goal, then that can really help to spur innovation. Mm-hmm.
The other hand, it may result in reduction of quality.
Yeah, definitely. Yeah, quality is one of the things that can be compromised if you're focusing too much on meeting a certain price goal. Yeah. And so, I think so, yeah. If it's good to set a budget for things, you know, if you say, I don't want to spend more than 1,000 dirhams on entertainment every night, then, you know, you'll keep within a budget, but sometimes you have to be realistic about what the money will actually be spent on so that you're not saving too much and compromising on quality versus saving too little. And so you really have to know what the circumstances are to decide between the bottom-up or the top-down approach. Does everyone understand what I mean by use the bottom-up approach for your project? Look at how much things actually cost to determine what your expenses will be. The amount of time you put into an estimate sort of has an impact on how accurate it is. And this is a conceptual figure that's provided by the text, and it says that if you only spend, for example, 10 minutes putting together a cost estimate, then it may be accurate only to plus or minus 30%. You know, that's a very inaccurate cost estimate if you may be 30% too high or 30% too low. On the other extreme, let's say that you spend 3 weeks estimating exactly like for your project. Let's say that you went to the grocery store and you figured out what is the price of rice, what is the price of a bottle of water, and you made a list of, you know, like 500 items that you think you might buy over the next 30 years. That would be too much detail. In your project, you don't need to break it down by the cost of a coconut, the cost of mangoes, and all of that. That would be too much detail. And so that would be so accurate that maybe it's good to plus or minus 5%, but you've spent so much time and money producing the estimate that you probably, the estimate cost you more than you're going to save by being accurate. And so the point the text makes is that you should try and balance the accuracy of the estimate you generate with the requirements that you have for making that estimate. Here's another figure, and remember that sometimes I like to just give you a figure and say, tell me a story of what this figure means. And so let me walk you through the concepts of this one. It's important. It's showing at the beginning of a project, there's a couple of curves here, so let me show you what the curves are. At the beginning of a project, you haven't spent any money. And so that's why these two curves are down at 0, is before a project begins, when it's just first announced, not only has no money been spent, but you haven't planned on where the money is going to be spent. These two curves, the one on bottom is how much has actually been spent, and then this next one up is how much you have committed to spend. Like it's not spent yet, but based on your planning, you've decided where it's going to go. Now, this upper one is showing you over the life of a project how much money you can save. What it's saying is, at the beginning of the project, you can save a lot of money if you make the right decisions. But as the project goes on and on, when you're building the project or when it's almost complete, since you've already spent so much money, there aren't very many things you can do to realize cost savings at the end of the project. So, you know, when you've already produced it and the customer is using it, the building is built, you know, you've already settled on the electrical systems, the plumbing systems, the heating, ventilation, and air conditioning. You know, when basically everything is finished, you're not going to be able to save that much money by switching from one paint brand to the other. That's going to give you a very small savings compared to all of the other decisions that you already made earlier in the project. And so the interpretation of this is that it's at the beginning of a project that you need to be the most careful about planning, cost estimation, and identifying suppliers who meet specifications at the lowest price, because it's at the beginning of the project, over here on the left side of the curve, when you haven't yet spent or even committed the most money. So any questions about this figure? All right. In summary, cost savings are the easiest to obtain at the beginning of a project. So that brings us to the unit method. The unit method as a concept is very easy. It's just saying if you know the price per unit, like how many dirhams per cubic meter of concrete, then you can find out the cost of a project by adding together all of the components, multiply the unit cost by the number of units required. And so you'd find out the cost of a bridge by saying the ingredients of a bridge are concrete, steel, labor, and land. And so you find the cost of each of those components and the amount of it you're using and multiply it together, then add the individual costs. So here are some examples that are provided by the book. That the average cost of operating a car, 52 cents per mile. So if you know how many miles you're going to drive in a year, you could estimate your transportation expenses by multiplying the number of miles by this rate. Same with a highway, a house, a concrete. So it's an easy concept. All right, does everyone have a copy of today's in-class exercise 36? Here's what we're going to do for the first one. All right. Our company has to manufacture 1,500 sections of gas pipeline, and so we have the ingredients for whatever we have to do for this gas pipeline. It includes the steel, production costs, labor, and indirect costs. So let's estimate the cost of the 1,500 sections by using each of these components. All right. So go ahead and work with the partner on that one, and then we will pause to take a look at the solution. So we're trying to find the total cost based on our knowledge of the pricing data and what our production costs will be. So it's just going to be the sum of all the components. So we know that the steel, for example, is going to cost $137,000. The machinery and tooling, $180,000, and so on. So if we add together all of the costs, $566,700. So this is an example of how you should figure out your expenses each year as you do an estimate of food and clothing and transportation, rent, and then you add it all together. Any questions about the first one? All right, so that was just cost estimating using the unit technique. For part 2 of the in-class exercise, we're going to go into decision making, comparing two different alternatives. So here's the situation. Let's say that we are working in a factory that makes iPhone cases, and we have the choice between two different kinds of plastic. One kind of the plastic is lower cost plastic, but it produces a lot of defects. And because of that, we can only make 57.1 of these cases every hour because so many of the cases are defective since it's a low quality plastic. That low quality plastic only costs 30 cents per pound, and we know how much, 0.0353 pounds for each case. Compare that to the higher grade plastic. It has a lower defect rate, and so instead of only 57.1 parts per hour, we can make 102.9 parts per hour. So that boosts the productivity a lot. And in a given month, we need to have 8,333. The marketing department has said that's what the demand will be at the price they hope to sell. But we don't know what the price is, and so we're not going to be comparing the price to the cost to learn the profit. We just want to minimize costs in this example. We'll choose whichever alternative gives us the lowest costs. This higher grade plastic costs $1.40 per pound and requires slightly more plastic for each case. And so what we're balancing is the materials costs are higher for this good plastic, but we think the labor costs will be a lot lower since we can make the cases more quickly. So in part A, what I'd like you to do is calculate the total cost per month for both the low quality plastic and the high quality plastic. Find out what the total production costs will be, meaning both the labor cost, these other variable costs, and the material costs for both low grade and the high grade plastic. And then in part B, once you've calculated those estimates on a monthly basis, find out how much this idea is worth on an annual basis. This is just some employee's suggestion to switch to the higher grade plastic. So let's see what the annual savings could be if the suggestion is implemented. I'm going to pull up the solution for those of you who are still working if you want to have a look. See ya. So it turns out that the high-grade plastic is actually cheaper because it saves so much in labor. On an annual basis, you should save, oh, it's not written on the screen there, $15,169.74.